right, your homework was reviewing some of the concepts we learned yesterday. So let's see how you did. Number 1, the first thing is we've got some bases to multiply. The 2 and the 5, since they are different bases, we simply multiply like any time we would when we see a multiplication sign. So 2 times 5 gives us 10. Now I've got x's. Now these are the same base, so when we multiply them, we're going to add their exponents. So I'm going to go 2 plus negative 5. So that's going to be x to the negative 3. And then I've got y to the 5th times y to the 3rd. Same base, so I'm going to add their exponents, which gives me y to the 8th. Well, yesterday we learned we're not allowed to have negative exponents, even if the directions don't tell you to. That is part of the rules of exponents. So I look at what's negative. I know I'm going to have a fraction here. So I look at the 10. The 10 does not have a negative exponent, so it stays put. Then I move on to the x. It does have a negative exponent, so since it's on top, it's going to cross the line and go to the bottom. The y to the 8th, well, that's positive, so it stays put. There's no other same bases, which means I know my answer is correct. Number 2, instead of multiplying, we're dividing. Now, here's where a lot of students make a mistake, and they try to go 9 minus 12. Are 9 and 12 exponents? No. So we do not subtract them. We divide them just like we would if it was simply 9 over 12 as a fraction. Well, 9 and 12 can both be divided by 3. So that's what I'm going to divide them by. So that's going to give me 3 on top. And that 12 divided by 3 will give me a 4. Now the next thing I look at are my m's. They're same bases. Where do I have more m's? There's more on top. So that's where they're going to land, and there's 3 more on top, so m to the 3rd. Now my n's, I have a negative exponent for an n. I'm not allowed to have that, which means this n to the negative 3 is actually going to go to the bottom and become n cubed. So now I've got this n here, this n here, so if you need to, fill in that invisible exponent of 1 for the n. So now since the n's are side by side, we're going to add their exponents, and that gives me n to the 4th. And there are your 2 answers for today's warm-up. Here are your 10 answers from last night's homework, so go ahead and check. I did try to show some work for the ones that needed it, and hopefully doing the warm-up also helped as well. With some of them, if you left the exponents with 1s, that's okay, like in 2 and 4 or 3, but we really don't want that. We just want the variable without the exponent if it's an exponent of 1. When there's more than one variable in the problem for the answer, such as in number 8, we do want to put them alphabetical order. And U comes before V in the alphabet, which is why it comes there. If you left it like this, it's not wrong. Just try to remember because that's how they'll be on multiple choice tests. What we're going to do today is continue working on some of the problems on this worksheet. You're going to work on about 5 or 6 at a time, and then unpause the video to check the progress, the process, and your answer and see how you're doing. So the first thing I want you to do, and you can get help from a neighbor as you're going through them, you're looking at questions 11 through 16. So go ahead, do them, and then when the class is ready to check your answers, unpause this video. Well, number 11 is going to be one of the easiest problems that you see. anytime you have parentheses and everything is being raised to the 0 power, the answer is simply going to be 1. Going over to number 12, we've got more than one thing inside the parenthesis, and it's not being raised to the 0, so we do have to do some work here. So I'm going to fill in invisible exponents, which this 2 has 1. So this -4 has to be distributed to both exponents. So that 2 now has an exponent of -4, 1 times -4, and the x now has an exponent of -8, 2 times -4. Well, we know our rules. We're not allowed to have negative exponents. Since there is not a fraction, I know that means it's all on top, which means anything that's negative exponent has to move to the bottom. So 2 to the -4 becomes 2 to the 4th on the bottom. X to the -8 also has to move, so x to the 8th. Well, since everything had a negative exponent, I have to have that placeholder of 1 on top, but there is a number here that can still be simplified, so 2 to the 4th becomes 16. So this answer is 1 over 16 x to the 8th. So the rules that you're looking for here are you can't have the same base and you can't have negative exponents. Those are 2 of your biggest rules here. Going over to number 13. Be careful on 13. Both things are not raised to the 0 exponent. The only thing that's raised to the 0 exponent is that r. Well, r to the 0 is 1, and 4 times 1 isn't going to do me any good, so I'm just going to cross that r to the 0 out. The 4 in the parentheses has that invisible exponent of 1. So when I take 4 and multiply it to the 1, I now have 4 to the 4th, and 4 to the 4th is 256. Number 14, inside my parentheses, I'm missing an exponent with that 4, so I'm going to go ahead and add it in there. So I take the 2 and I distribute it to both of those exponents. So it becomes 4 squared, 1 times 2, and a to the 6, 3 times 2. There's no negative exponents, which is good. I don't have any of the same bases. The only thing left to do is to take that 4 squared and make it to 16. "15 is very similar to number 14. We're going to put that invisible exponent with the 3, distribute the exponent of 4. So I have 3 to the 4th and k to the 16. And I know that 3 to the 4th becomes 81 k to the 16th. Last of these 6 before you start doing some more. Number 16. This time the exponent that we're going to be distributing is a negative. Well, let's fill in the missing exponents here. And it's actually all of them have the missing 1. So when I distribute that -1, they're all going to be exponents of -1. Well, negative exponents means I'm going to end up with the fraction. The 4, the x, and the y are all attached to a negative. They're all on top, which means they're all going to move to the bottom for that exponent to become positive. Since they all move and there's nothing left on top, I know there's a 1. And now keep in mind, yes, you could leave this as your final answer, but we typically don't see exponents of 1. So just 1 over 4xy. Alright, next I want you to work on 17 through 22. Same thing, work through these, work with a neighbor as needed, and then unpause the video when you're ready to check all 6 answers. So starting with number 17, let's look for missing exponents here. And we're missing an exponent with the 2. So we distribute the -1. So I have 2 to the -1, b to the -4. Negative exponents means I need to create that fraction. The 2, since it's on top, goes to the bottom. So does the b. Well, they both went, which means I need a placeholder of 1. And again, we really don't want that that 1 there. We don't need it. So 1 over 2b to the 4th. Let's go over to 18. 18 inside the parentheses, I'm not missing any numbers, so we can go ahead and distribute. So it's going to become x to the 4th and y to the -2. Well, I still run into a negative exponent, which means I need to have a fraction. This time, however, the x to the 4th is not negative, so it should have stayed put on top. And only the y should have moved to the bottom, becoming y squared. (19), we do have an invisible exponent there. So fill that in. We're distributing the -1. Now, for some of you, you might have been approaching this differently, and when you saw the negatives, you might have been saying, well, I know everything's got to go to the bottom, so kind of like you're flipping it. However, this one, because there was a negative already inside, you can't just flip the expression. So we're going to distribute the -1 to each exponent. So this becomes 2 to the -1, x to the -5, and y to now the +3. So we have negative exponents, which means we're going to have to move things. So the 2 to the -1 goes to the bottom as 2 to the 1, or just 2. The x to the -5 goes to the bottom, but the y cubed stays put. No more like bases, no more negative exponents, so this is our final answer. Going over to 20. This one, we have 2 invisible exponents. So we distribute the -2. So I have 3 to the -2, m to the -2. Both of those have to go to the bottom. So I have 3 squared and m squared. 3 squared can be evaluated. So my answer is 1 over 9 m squared. Number 21, we don't have any negative exponents. What we do have are same bases. So we have to simplify those. So I look at it and I've got an r squared on top, which means 2 r's, and r cubed on the bottom, which means 3. So I have more r's on the bottom than on top. I've got 1 more r on the bottom, or just r. This 2, since it's on the bottom and there's no negative exponent, just stays there. Since we took care of all of the r's from the top, I have a placeholder of 1. Looking at number 22, this one we do have negative exponents, so we need to move them so that x to the -1 needs to go to the bottom as x to the 1, or just x. On the bottom, I already have a 4 and an x to the 4th. Well, there was nothing left on top, so there's my 1. I now have same bases in the denominator. Even though it's a fraction, since they're both in the same location, I'm going to multiply them to get x to the 5th. That 4 comes out front, so 1 over 4x to the 5th. Go ahead and try 31 through 35. If you don't have time in class to finish listening to the explanations, then you need to go onto YouTube tonight and finish this video. But again, take your time, 31 through 35, and then when you're all ready to start checking answers, unpause the video. On 31, you can do this one a couple of different ways. I would recommend going ahead and simplifying inside the parentheses first, since they're both the same base, and that's going to become x to the negative 5, since we add them. You also could have distributed the 4 first, and then simplified it. It doesn't matter, but this way it is a little bit easier. So now we have x to the negative 20 when I multiply the negative 5 and 4. I'm not allowed to have that negative exponent, so I know it's going to go to the bottom. There's nothing left on top, so there's my 1. 32, we need to take care of that negative 3 on the outside before combining my bases. So since that negative 3 is up in the air like that, we're going to multiply 4 and negative 3, which is x to the negative 12th, times 2x to the 4th. I've got same bases here. Since I'm multiplying, I'm going to go ahead and add them. Bring down that 2, and I have x to the negative 8. Well, I still have a negative exponent, so now the move is to get rid of that. That 2, however, is not attached to the negative exponent, so it stays on top. And the x to the negative 8th goes to the bottom to become x to the 8th. (33), again, we still have some multiplying to do before combining my like bases. So this n should have become n to the 9th times 2n to the negative 1. Combine my like bases here. We're multiplying, so we're going to add the exponents. Bring down that 2 again, and I have n to the 8th, 9 plus negative 1. My exponent is no longer negative, so there's my final answer. 34, before I can put these together, I do have to take care of this exponent here. I've got 2 missing exponents that I'm going to distribute it to. So I now have 2 squared v squared, and I'm multiplying it by 2v squared. Now, you've got a couple options here. You could do 2 squared, turn that into a 4, and then go 4 times 2. Or you could go 2 to the first, and then since these are same bases, you would add their exponents, 2 plus 1. I'm going to go that route. Now, notice I didn't go 2 times 2 on this route, because when they're the same basis, we only take care of their exponents. And then v squared times v squared is v to the 4th. 2 cubed is 8, v to the 4th. No more same bases, no negative exponents. So here we go. Last one to check. Number 35. So we've got lots of the same bases here. So the first thing I'm going to do is take care of the numerator and try to simplify that, and then I'll worry about the denominator. It's not the only approach to this problem, it's just the approach I'm going to take here. So I'm going to take my 2 times 4 times 3, which is 24. I'm going to put all of my x's together on top here. Remember, this x has a 1. So 2 plus 2 is 4, plus 1 is 5, x to the 5th. And then I've got my y's. So those become y to the 8th. On the bottom, 3, x to the negative 3, y squared. Well, one thing I know is this x to the negative 3 needs to move up on top and become positive. I also know that I can take 24, divide it by 3, and get 8. So now I have 8. When I put those x's together, 5 x's here, 3 here, makes x to the 8th. I look at my y's. I have 8 on top, 2 on the bottom. There's more on top, In fact, there's 6 more on top. So y to the 6, which means I no longer have anything in the denominator. So there's my final answer.